everybody, welcome back to another Nielsen Networking video. The video ahead is actually the third video of a three-part video series that we put out on YouTube titled DNS Explained. And this series is meant for anyone serious about learning the how, what, and whys of DNS. Now this could be anyone from a pen tester, system administrator, or ethical hacker, or just anyone who wants to know more about DNS. I will recommend, if you have missed the first two videos in the series, I would go back and watch them first, as they cover the foundational DNS concepts that you'll need to fully understand and appreciate this video's materials. And now with that out of the way, I will tell you that this video is going to focus on three types of DNS-based attacks that a penetration tester or an ethical hacker may use to compromise or abuse DNS. Now, on the flip side of that, you'll also learn, if you're a system administrator or a security professional, how these attacks are taking place and how you can prevent them. So with that said, let's just get right into the first attack. All right, for this video, I'm going to be using my Kali Linux box here with VirtualBox loaded on it and 3 Kali Linux machines loaded inside VirtualBox. One of them is going to serve as the client, one's going to serve as our DNS server, and one of them is going to serve as an Apache web server. So we're actually going to go ahead and start on our client machine here, because we're going to be talking about something known as local DNS hijacking, or sometimes called client-side DNS hijacking. All right, what are those attacks exactly? Well, when an attacker gains administrative access to a device. Now, this can be done remotely via malware, malicious script, malicious website, or in person through physical access. Let's say there was an admin and he had to run to the restroom, or he needed to go smoke, or he needed to go to lunch, whatever. He left his machine non-secure, like he didn't put a lock the screen, and he just left, right? And let's say you just happen to be doing an on-prem pen test, and you're walking by and you notice, well, this isn't a secure machine. You sit down, maybe you don't even know it's the admin machine, right? But you decide, well, let's just, let's do a local DNS hijacking attack here. So you go in and you modify their network configuration to change their DNS server settings to point to your rogue DNS server instead of their, ISP, or maybe they're using Google's 8.8.8.8 or whatever. You are changing it now to point towards your DNS server. Now, why would you want to do this, you're saying, right? Well, you'd want to do this because now that any DNS requests that come from that person are going to get redirected to your DNS server. And once it gets redirected there, guess what? You get to tell it where it's going. So this can be anywhere. It could be the third Apache web server I have in a lab here, right? You put up a facebook.com or a Bank of America, whatever, put up a page that looks like it with a login. The user goes there, doesn't realize it's a fake site, put in their credentials, and boom, you capture those credentials. Then, or you could even do it like a company SharePoint or Microsoft for lateral movement. There's lots of things you could do once you actually get access, whether, remote or in person. So that is how it works. Now, how does it actually work if we were to show you an example here? I'm glad you asked, and I'm going to show you right now. All right, now most of the client machines you'd probably be targeting, or, because the majority out there, it's going to be Windows clients, right? I'm on a Linux box, so I obviously can't show you that. But if you were going to do this on a Linux box and you wanted to update the server, you can just do it via a PowerShell command. This would be the PowerShell command to do it. Obviously, if you're doing it through a script, you'd put this in your, whatever you're using to put the script out there. I don't know if it'd be JavaScript or Perl, if anyone uses Perl, or Python, whatever you're using, right? You'd programmatically do this. But I'm on Linux, so I'm going to show you the way we would do it on Linux, which it's the same concept, just a different a way to do it. So what we're going to do is we're going to go nano, and we're going to go to this file right here, which is an etc, and it's called resolve.conf. I'm going to go in here, and right now you'll see I'm set to 8.8.8. Google's names are down here. I have this one commented out, and we're not going to use it yet. We're going to look up google.com, make sure we get, this is actual real google.com. And let's look up nielsennetworking.com. That's actual nielsennetworking.com. If we go out here, go over here, go to nielsennetworking.com. And when it decides to load, which it just did, or google.com, you can see those are the actual sites you would expect, right? Cool. So that's all great. Now we're going to go in and we're going to act like we compromised this, whether it was physical, whether it was smoking, pooping, whatever he was doing, or we did this remotely for whatever, through whatever means, I mean. So what we're going to do is we need to edit that file, right? Boom, we did this. We're going to go in here. We're going to either delete the file and replace it, or we're going to comment it out, whatever, however you want to do it. As long as your name server is the first one in the list, you're good to go. We're going to go ahead and save it, clear this out here so you can see it. And now let's go ahead and look it up. Okay. You can see it's pointing to an internal right now because it's a lab. This would be wherever you wanted it to go if you were doing this. And then out here, Google, right? Go into the same place. Now, in theory, if we go out here, this should take us to a different page, right? And let's just do google.com. And there you go, boom. Now, this isn't exactly a DNS poisoning attack. We'll get into that in a minute, but it's in the realm of DNS poisoning. So the landing page is going to say DNS poisoning. Now, same thing if we go to Nielsen Networking right here. Okay, well, this one isn't cooperating. Let me just check something. I'm just wondering if it's cached here. So let's try that. Let's try. Oh, I'm wondering if the record, and we'll look at this in a minute. Maybe it requires. I'm really honestly not sure why that's not working. Let me try one more thing here because this irritates me. Clear recent history. Clear it all. Let's try it one more time. We do it live here, no retakes. Nielsen Networking.com. There you go. All right, it must have been cached or something. Anyway, so the point is we can control wherever we want this person to go, wherever we want them to land, I should say. All right. Now, this could be, instead of my ugly little DNS poisoning, I just wanted it to get your attention. We could have it be, again, a landing site for Microsoft to get credentials there. This could be a bank, whatever you wanted. That could be whatever you wanted. So that is how that attack works. And again, that's going to be client side. So now what I want to do is shift gears and let's take a look at the actual server here. And let's see what it would take to actually compromise this and do this server side. All right, and a server-side attack like this is going to be known as an authoritative DNS hijacking or a DNS zone file compromise, with the latter probably being more accurate for what I'm going to show you right now. And in our previous example, it was client-side. Only one device was lied to, I guess you could say. When the authoritative server, meaning the server itself, is attacked, the attacker is changing like a master. We're changing the zone. So it's like overwriting back in the day, if you remember, a phone book. So it would say, nielsennetworking.com, call this number. Now we're just changing that number, and anyone that has that phone book is going to now have that wrong number. So the attack is much larger. It's much more persistent because most people are going to find out pretty quick when a client versus, if this is thousands of people, and it's also going to get replicated downstream to other servers depending on where you do this, right? So and we can go into that in more detail in another video, but obviously if you watch the first three, you would understand that DNS servers replicate to one another, right? So anyways, what we're going to do in this video is I'm going to show you where the actual zone files live and what it would look like to compromise one of them, and then we'll go back to the client machine and see what it does. Okay. All right. And again, I'm going to do the example in a Linux environment. If this was Windows, you would need to do this to the Windows domain server, which is, probably an Active Directory, or I guess it could be standalone. But anyway, or it could even be on a switch or something, wherever your DNS settings are. So anyways, for Linux, which we're on now because Linux is the best, we are in the bind directory. And if we do a listing here, we can see there are several files. Now, these DB ones are actual individual zone files. So if we cat one of these, like a DB, let's see what we got. Let's just do Google, I guess. You can see it has all the information. And this is actually, whoops, I don't want to do that. This is a compromised zone file because this is one I've actually modified. And that's annoying. And we'll get to that in a minute. But the most important file we're looking for in this directory is going to be and I'll show you, we'll do it right here, the named.conf.local. Now this is going to be where you tell bind what actual zone files to load. Otherwise, it's just going to use whatever its forwarding address is. Right now, right now how this is going to work is if I look up any other address but these two right now, it's going to go out and it's going to send me to the forwarding address, which is actual Google servers. So it's going to go out and look up Google. But since these are here, this is kind of like a host file. That's priority. Anything in here gets looked at first before it goes out. So since I've compromised this, I've actually told it to go look at these two zone files for these two specific websites. So when the client goes and looks at them, they're going to get this information. So what we're going to do out of here, we're going to go that, and we're going to go back over here to our client. And we're going to go here. And what we'll do is clean it up. And we'll still verify when we do an NS lookup that Nielsen, am I on the right machine? I thought it would have pre-filled. If I could type. That's why I didn't pre-fill. It's still pointing at the wrong server. Okay, so it is. So right, let's go back over here now. And what we're going to do is we are going to go back in here and we're going to comment out this. We'll do Google. So what we'll do is we'll do a / here. I mean, you could just delete it too, but since we're going to want to add it back in real quick, I'm just going to go ahead and leave it alone. And then what we'll do is we'll do to comment it out, right? And we're going to go ahead and save it. And then we're going to go ahead and do, why doesn't it pre-fill? RN, oh, there it does pre-fill, sweet. All right, we're going to reload it. So this just reloads the name server. So then we're going to go over here, or bind, I should say. We're going to go back over here, and let's look it up when we do Google. Look, suddenly that's still there. But if we do NS lookup, NS lookup for Nielsen networking, it still gets the wrong address. So that's the power of this, right? We're over here. We now control this. And this, the reason I just commented it out, obviously, you could just have deleted it and it would do the same thing, or maybe it was just never added, right? But you could add any other entries you want. And as you add those entries, right, you go back over here and you go back to the entries over here. And let's look at nano db.google. You could see you could put whatever record you want in here. Now, instead of www, you actually could just put whatever. It could be like a text record, whatever. It doesn't have to be. It could be whatever type of record you want, you could put in here. Sorry, I couldn't think for a minute. That whole screen capturing thing was irritating me. So that's how a client side would work, right? You would go in here, you would take this over, you would edit that file right here, and you would add whatever zone files you want to it. And once those are added, anytime a client goes to them, it's going to redirect to that site you told it to go to. So that is a much more impactful global something. Chances are, like, this is something you're going to do internally. I doubt you, unless you're crazy, you're going to go out there and like hack a Google name server or something, right? Obviously, you wouldn't have permission to do that, and you'd get arrested and go to jail for the rest of your life. But this is something you could do internally during a pen test, and something you should try to do. See if you can get access and do that and see, because it's a perfect way to get lateral movement, right? But again, doing something like that externally or without permission would be a very bad idea, and don't do it. So how can you protect against an attack like this, right? Well, to protect against this attack, you could use something like encrypted DNS or DNSSEC, or on the client, you would use endpoint protection and pray it actually works, right? Those are things you could use to prevent these type of things from happening. Obviously, your protection would be put a screensaver password on, use multi-factor authentication, harden your devices. Like I could go into a million things on how to prevent it. But this is how, if you actually were doing a pen test and you were able to get in, this is what you would do to compromise those. So that said, let's move on to our third and final attack. All right, and the third attack I want to show you is known as either Etter or Eater. I don't think it's Eater, but it could be. We'll go with Ettercap. Ettercap is going to be built into Kali. So it comes loaded with Kali. You do have to configure it, and I'll show you that real quick. But what it's going to do is, it does a lot, actually. It's kind of like a Swiss Army knife. But what I'm going to show you quickly is DNS poisoning. And what we're going to do is we're going to perform a man-in-the-middle attack. So what we're going to do is we're going to go in and we're going to the first thing you need to do is edit the config file. And actually, yeah, okay. Well, I should mention before you do this, because it won't work, and then I'll get a ton of comments. The first thing you need to do, and why I had named not working, was you need to stop name. Because what we're going to do is we're going to intercept traffic and we're going to act like a DNS server. So what we need to do is actually stop our real DNS service from running, because it's locking port 53, which we need for Ettercap. So I'm going to go ahead and I'm just going to stop it using this command. If you're not running named, you don't have to do this, obviously. And then we need to edit we need to edit. I was going to do edit like I was in DOS. We're going to go ahead and go to Etsy. There you go. Pre-filleds are awesome. And what you're going to want to do is you're going to want to go down to the bottom. It tells you exactly what to do here. And again, there's a million different things you could do here. But what you're going to want to do is you're going to go down here and you're going to want to put your entries. And these are the entries we're going to hijack. So when anyone goes and puts in nielsennetworking.com or /.org, specifically Nielsen without, the www or with the www, or down here /.org. And then I did a wildcard because this actually captures everything. So the easiest way to do this, unless there was a reason. Now, let's say you didn't want the subdomains all to appear the same, then you wouldn't want to do the wildcard. But for a demo, I just wanted to do the wildcard. So you go ahead and put those in. So you'd put in the domain, the record type, and the IP address. And if you don't know what the record type is, you should have watched my other videos. So we're going to go ahead and do this, and we're going to go here. I already have it configured. And now we're going to go ahead and run the actual Ettercap command. All right, and I am lazy or efficient, and I'm just going to go ahead and paste this command in because it is way too damn long. All right, so what we're going to do here, and I'll run it through. First thing first, if you are not root, you're going to need to sudo this, right? And then what we're going to do is the T is going to be a text mode. So it tells it to run in a text-based interface rather than launching like a graphical interface. And I'm on the command line, so obviously this is what I'm going to want to work from the terminal. Q is quiet. This keeps the output quiet by not displaying every single packet that passes through. If you wanted to see it, because you wanted the cool factor or whatever, you could not use Q. But you're gonna get just enough traffic, and you'll see it the way this is. Okay. P is gonna mean DNS spoof. It's a plugin. Plugin is gonna be the actual DNS spoof right here. So that again comes with Kali. We're gonna tell it use this plugin, right? And M indicates ARP poisoning attack. So this is going to be it. And then we're going to tell it the remote, and these are going to be our targets. So 10, I keep saying, 10 is right. 10, 0 to 11 defines who's being targeted. This is going to be the client machine. And then this right here is going to be the gateway. Okay, so that's what you're going to need to do. You do need to put the slashes in here. Everything, it needs to be exactly like this. And we're just going to go ahead and run it. And it's going to tell you it's running and it's chilling right here and it's waiting. And now this could be done on a local network, Wi-Fi network, wherever. We're going to go ahead and do this. And then what we're going to do is go over here. And remember, I'm going to go ahead, just so there's no trickery here. And I'm going to make sure we are calming it out on that. And we're back on Google's, right? So when we do clear and we look up Google, or we look up, don't know why I just did that, nielsennetworking.com, well, that one's still going to the old one. That's interesting. I wonder why that do it. I might have to refresh it. That's strange that Google would think. Oh, never mind. I'm an idiot. You know why it's doing it? Because it's working. I forgot we had Ettercap running over here. Ettercap's working, and you can see it just spoofed it. So it already intercepted our traffic and is redirecting it. And you can tell that because right now, let me kill this. And we go back over here. I gave myself a heart attack. I'm like, what did I do? And we go back over here, and we're getting the actual one. Now, if we do the same thing and we go to /.org, we get that address, right? Now let's go back over here. Start this back up. Go back over here. Not there. Don't know why I did that. Go over here and let's do it again. /dot's going to where I want it to go. So is that. Let's check our famous little website over here with that awesome landing page. And let's go to /.org. Boom. There you go. DNS poisoning. Simple as that, built into Kali. May or may not work. The reasons it wouldn't work is for a few reasons. If you're on a Wi-Fi network, a lot of access points actually use something called access point isolation, where the access points don't actually talk to each other. So it wouldn't go out and automatically do it. It stops the ARP spoofing. They also could use something called ARP and DNS snooping, which would, again, kill the spoofing or poisoning, sorry. So that in a nutshell is how DNS can be used as attack attacks too, you know, lateral movement, phishing, not phishing, like a watering hole, I guess it would be. I don't know. I said phishing. Phishing is the most common attack you see, actually. So anyways, that's what's going down here. I hope you appreciated this video. I would have made this a little bit longer, but YouTube's been a little bit of a headache for me lately. So I'm hoping things go smooth with this video. And if you appreciate it, give it a thumbs up, like and subscribe. Let me know. I would be interested in showing, you know, more about these programs and more that we can do. But the last video on DNS didn't get the greatest reception, so I didn't want to spend too much time for something maybe if the audience doesn't have a lot of interest in it. So I think it's great. Personally, I think the second video was really great. It just didn't get a lot of traffic. So anyways, take care. I'll talk to you later.